Here we have a graph of velocity in meters per second versus clock time in seconds. We want to know now what's the interpretation of the area under this graph. Now, in the first place, if we're given just two graph points, we don't really know what the curve looks like. We don't really know how the velocity is changing with respect to clock time. The best estimate we can make is that it's a linear change, which would correspond, of course, to a uniform acceleration. Okay, well, if we look at the region under the graph, we see that it has a width that goes from 2 seconds to 8 seconds, which means that the width represents a time interval of 6 seconds. Now over on this side we have an altitude of 4, which corresponds to 4 meters per second. On this side an altitude of 8, corresponding to 8 meters per second. The average of those two altitudes is 6 meters per second. Now that's going to correspond to the altitude at the midpoint. But the average altitude is then 6 meters per second. Now I really should use arrows with just one head here. Delta T does move in the positive direction. Now to find the area here, it should be clear that the area under trapezoid, we've talked about this, is equal to the average of its altitudes times its width. And we can easily see that if we used a rectangle. See, we can form a rectangle here whose altitude is equal to the average altitude and whose width is still the width of the trapezoid. That rectangle contains a triangle here that the trapezoid doesn't, but of course it cuts out a triangle here that's part of the trapezoid. And the part that's cut out of the trapezoid and discarded, if we just take the area of this rectangle, is equal to the area that's missing over here. So that the area under the rectangle is equal to the area of the trapezoid. And therefore we're safe in multiplying the altitude by the width. Well, the area then equals 6 meters per second multiplied by 6 seconds, which gives us 36 meters. Now again, a convention that I use, I represent areas by a number circled somewhere at least reasonably close to the middle of the area that we're talking about, at least somewhere inside the area. So the area of the trapezoid is 36 meters. Now what does that mean? Well, the 6 meter per second average altitude represents our best guess at the average velocity. Again, remember, we don't know that the velocity is changing in a linear fashion. We don't know that we have uniform acceleration. But if we do, that's going to be our average velocity. And the delta T is the time over which that average velocity is in effect, so that when we multiply average velocity by the time interval, we get the displacement. So the area under the velocity versus clock time graph is the displacement corresponding to that time interval, the time interval defined by the 2 points.